Oh my
Hi
god.
guys,
I
welcome
got
back
this.
to
I got
Math.
this.
We're with StackHack here. Nithin from StackHack. He's gonna be helping me today in some explanations of these circle problems with many theorems. So this first problem we did here used the
Secant,
secant
tangent,
tangent angle measurement
theorem.
theorem. So we just got that. So we need to put the equation here. We plug those numbers to get this arc right here. We got 68, and then
So
using 360 minus 180 plus 68, we got this final measurement. So let's move on to the second one.
okay, so just as a quick, better explanation of number one, the secant tangent theorem basically says that if you take the bigger arc that the inscribed bigger arc, right, minus the smaller inscribed arc, which in this case we didn't know it was 68, but we called it y, and divide that by 2, you'll get this angle of the angle created by the tangent and secant, which is 56. So we can set this as an equation and write 180 minus the smaller inscribed arc, which was y, and then subtract it, which would make 56 times 2, because we're just taking the half and bringing it over to the other side. So it's 112 equals 180 minus y. Y eventually becomes 68 if you solve it out. And then, since we know that a circle is 360 degrees, subtract 180 from that, which is 180, and then subtract 68 from that, makes x equal to 112. So that's explanation for the first one. For the second problem, we already know that if two chords are congruent, that means that the angles created by the uh, arcs are also congruent, which means that x would be reciprocated on the left side as well. So 2x plus whatever that y value is, which Jeffrey has kindly called 130.
Wait, no. What are you saying? This is an inscribed angle.
Yeah, okay, yeah. So
So
your inscribed
65.
angle is 130. And so then that means that
What?
130 plus 2x equals 360,
Oh, we're
because,
looking for x. Oh.
and then x will eventually, if you subtract 360 by 130, it becomes 230. Yes, 230 divided by 2 is 115. So x is equal to 115. Now, for the third problem, uh, this is more of a systems of equations problem, and Jeffrey has kindly called the smaller inscribed angle as y. And as we said before, since the same formula applies for the tangent angle measurement theorem, we would say that the equation is x minus y is equal to x minus y over 2 is equal to 42. But just for simplicity, we'll just multiply the 42 by 2, which is 84. So x minus y is equal to 84 is the first one. But we can also, since we know that x is one of the angles, we know that y is equal to 360 minus x. So we can just plug that in. X minus, and then in parentheses, 360 minus x is equal to 84. Then if we distribute the negative, it's x minus 360 plus x equals 84. Now if we bring the 360 over and then combine the two x's, we get 2x is equal to 444. Then if we divide by 2x is equal to 222. This means that x is equal to 222. And then we could check our answer by plugging in the 222 into the y. So since we know that y is equal to 360 minus 222, y would equal 138. Now if we plug this in, so 222 minus 138 divided by 2 is equal to 42. So we know that that's the right answer. So now number 4. Okay, number 4.
So we know this is the center because it shows here, so this is the diameter. So this arc will have to equal 180. And we're given 2 of these arc measurements already, so it's going to equal up to 78. So the only other angle arc here you can deduce from there is going to be 102. Using that information, you then have the secant tangent measurement
Secant.
angle, secant angle measurement theorem, where you have these 2 arcs and you have this inscribed angle here. So the way to do that would be half of 102 minus 30 is equal to x. And solving that out, you get 72 half equals x. Half of 72 should be 36 equals x. Is that right?
Yep.
Okay.
Now number 5. Oh, do you want to do it, Jeffrey?
You go ahead.
Okay, sure. So since we know that the major arc is equal to 235 degrees, then the minor arc will be equal to 360 minus 235, which is 125. Now that since we know that since we know that there's a theorem basically that says that that chord tangent, that combination is equal to half of that inscribed angle, which means that x is equal to
I
62.5.
think it's called a tangent chord theorem. Tangent chord theorem.
I think you're right.
Yeah, I'm
Okay.
not too sure though. No.
Yeah,
So
but just know that that's a thing, and what it is. So x would equal to 62.5
Nithin,
because
do you have any idea what this tan could mean? We saw this tan on this line here and on this triangle.
yeah,
here.
sure. So the tan is basically just a tangent, and it's just there to further. It's just a hint, to make sure that to guide you in the right direction and to tell you, yeah, use the tangent chord theorem. So although sometimes you won't see it, when you do see it, just know that it's sometimes a hint.
So is this tangent saying that there's only one point hitting the circle, or is the tangent meaning something else?
Exactly. There's only one point that'll hit the circle or intercept the circle, and that's
Okay.
basically what happens in what a tangent is.
Okay. Move on to number 6. So in here we're going to use the intersecting chord theorem, and we take half of this arc and half of this arc to find the intersected angle here. So that'll be 55 plus 55, because these are both congruent chords. That means their corresponding arc will also be congruent. So this will be 110. My dog was lagging. Okay, so these will both be 110. And then once you have that, you take 55 plus 55 using that theorem, and you get 110 as this angle here. You can then use the supplementary theorem to say that 110 plus x equals 180, and that x will equal 70. So that's for number 6. Let's go to number 7.
Yeah, and actually another way to do number 6 is if we call the arc to the right, the minor arc to the left, I mean A. Do you see that arc? Jeffrey, could you label it?
Yeah.
A.
Yeah, Doc was
Yeah.
laggy.
And then if you call the other one, the one to this other side, right, to the right side, as B, right? Then we know that A plus B is equal to 360 minus 220. And the reason we know that is because 220, the way that I got 220 was because since we have the congruent chords, that means the arcs are also congruent, meaning the other side, the top one is 110 as well. So that means that the total, those two add up to 220, sorry. And it's 360 minus 210 to get A and B, the remainder. And then from there, since we know that the chord angle measurement theorem says that A plus B over 2 is equal to that angle, right? Then, and since we already know A plus B, which is 140, if we divide it by 2, we get 70. So that's that.
Okay. So number 7, you can do this one.
Yeah, so
Let's continue on with these problems over here. So these two chords are parallel. You can use the theorem that this intercepted arc will be congruent to this intercepted arc. So you can deduce that this will be 40 and this will be 40 as well. Now you also know this is the center, so this arc will have to equal 180. You already know that these two equal to 80, so this has to be 100. That's your final answer. Alright, going to 8, we're looking for this angle here. So we automatically see that we might be using the tangent chord theorem here. And now we just gotta find either this arc or something else we can use. So we see that this is 120, this is an inscribed angle of 40, and deduce that this is 80. So 120 plus 80 is 200, so this has to equal 160, this arc right here. And using that theorem, this angle will be half of this, so that'll be 80 degrees, x will equal. Alright, moving on to number 9. We're looking for this inscribed angle here. This is looks hard, but it's actually pretty simple. If you think about it, just looking at these two lines right here, it's talking about this arc right here. So we know that 81 plus 82 is 163, so this arc right here equals 163, and the remainder of the circle will be 360 minus 163, which is 197. And that'll be your final answer here. Oh, sorry, not your final answer. So you get 197 as this angle, and this is an inscribed angle, so it takes half of the intercepted arc. So that's going to be 98.5. And that's your final answer. Moving on to number 10. Let's see. Okay, so number 10, you're looking for x and y. So off the bat, we're going to have to be using both theorems of intersecting chord measure theorem and second tangent inscribed angle measurement theorem. So using those two theorems combined, we're going to look for if I'm going to set up a system of equations. So this is going to be half of x plus y is equal to 65, and then half of x minus y is equal to 24. So using these two together, we can then first we need more space. It's unfortunate. We're gonna go up top here, so we can eliminate these two. We get x here is equal to, add these up, 89. Okay, so x is equal to 89 here. Then you can plug it back into any of these problems here. We'll go with the addition one because it's a little easier. So 89, half of 89 will be 44.5. plus half of y. So then 65 minus 44.5, you get 20.5 times 2 is equal to 41. So y is equal to 41. Alrighty, let's go to number 11. So you get these two parallel lines. You can say that this angle here is also going to be 55 because you have two parallel lines and you can use alternate exterior angles are congruent, the theorem, to say that these two angles are congruent, so that's 55. Then using tangent chord theorem, you can say that this arc here will be 110. So you get that arc is 110. Then using this described angle, you can say that this arc will be 110 as well. So you got these two arcs measured up, and you're looking for this arc. So it's going to be 220. So 360 minus 220 is, my math is just not good enough to use a calculator, so it's going to be 140. That's your final answer here. Move on to 12. So we're looking for AB, this angle here. So we're going to have to solve for x. So in order to do that, we're using the intersecting chord measurement theorem, which is going to be half of 2x plus 5x plus 6 is equal to 94. So so you can add these things together inside. 94. And actually, I would prefer just to multiply the 2 out of this equation. So multiply 2 out of that plus 6 equal to 188 minus 6 minus 6, 120, 182. Yeah, 182 equals 7x. You get x equals to 26. Alrighty. Now we're moving on to this last problem here. These last few problems here. Given that measure of 7 is equal to 60, let's just write this out. So this is equal to 60. Measure of BF equals to 120. Where's BF? BF angle, oh sorry, arc BF is equal to 120. Arc DE is equal to 60. CD is equal to 40. AG and AF are tangents, so these two are tangents. Find the following measures. Okay, so BCF, arc BCF, BCF. That's the major arc here. So you have all these things here. So what you're looking for here is going to be this final arc, and to do that, you can add all these. So oh wait, hold on. First, before you do that, you realize that I forgot. This is not the arc. This is the measurement of this angle, but you can easily find the arc because this is the tangent chord theorem. So you can use the tangent chord theorem and get this arc right here. So that's going to be 120. Oh yeah, I almost messed up again. This is not in fact 120. If you're looking at this entire chord, it's actually talking about this entire arc. So in fact, this arc right here is also be 60, because 120 minus 60 here, this existing 60, then you can get that arc. So that's going to be 60. So now you just plus these all together because they're all the arcs. 20 plus 60, 120 plus 60 plus 60 plus 40. So 280. So that'll be, so this last angle here would be 80. Okay, so BCF would be 80 plus 40, 120 plus 60, 180 plus 60, 240. Okay, measure of angle 1. Measure of angle 1. You know, this arc is 120, but since you can use the tangent, secant, and inscribed angle theorem, so you have you have this major arc which you just solved for, which is 240, looking for 1, so it's going to be use the formula 240 plus, sorry, not minus, it's minus 240 minus 120, half of that equals to 1. So that'll be 60. There you go. Okay, so now DF. We already solved that. It's going to be 120 because you're simply just using the tangent chord theorem. And then you have arc EF, which is going to be 60 as well, because remember we just solved for that right there before, talked about it. So for here, so you're using the intersecting chord theorem here. You have these two measurements, 60 and 40. We're looking for 4, so that's going to be half. Okay, so 40 plus 60, 100, and half, 50. That'll equal to 40. So that's just, you guys are a little confused about that. You can go back further in the video when we talk about this theorem, basically when you just have these inscribed chords. So BC now. BC would equal to 80. That's, I think, yeah, thought that was given to us. Yeah, that's just weird. Never mind, we did solve for that. My bad. We solved for that. Okay, 2. Measure of angle 2. So 2 is right here. And again, this is the same tangent chord theorem. So if this corresponding arc is that, 2 would be 40. Because 80 divided by 2 would be 40. So measure of arc of BFE. BFE going this way. Okay, so BFE will be 120 plus 60, 180. Measure of angle 3 will be described angle of 120 plus 60, which is 180. So the angle will be 90 degrees. Measure of arc of FBC. FBC. That's going to be 120 plus 80, 200. Measure angle 5 is going to be, so we have 60 here, we have 200 here. We use the same theorem, the intersecting chord theorem. So 60 plus 200 is 260 divided by 2. It's 130, and that would be 5. So 6 is 6. 6 is right here. So this is the secant tangent inscribed angle measurement theorem, and you take this bigger arc on the outside, which is going to be 300. So 300 minus the smaller arc 60 is 240 divided by 2. It's 120. So that was the theorem we also talked about early on. So if you're confused about that, back in the earlier video and figure that out. So measure of angle 8. So measure of angle 8. This is the same theorem as we used in the last problem. That's going to be 120 minus 40, 80 divided by 2, 40. So measure of 9 now. Measure of 9 is going to be the same thing as the previous two. 60 plus 120, 180 minus 80, 100, and then divided by 2 is 50. So that's for that big problem. Alright. So find x in each of the following. Lines that appear tangent should be taken as tangent. Alrighty. So let's see. Okay, we're gonna find x. So this is 120, this is the center, so this is going to be 120 as well. This is going to be 60 because this is the diameter and each side will equal to 180. So you have 60 and 10 for that. So using that theorem we talked about, the secant-tangent inscribed angle theorem, 60 minus 10, 50 divided by 2 is 25, so x will equal to 25. We're looking for x here. So we're using this arc and this arc here. And this is an inscribed angle, so this arc is given to us as 30 because our inscribed angles are half of the intercepted arc. So 30. We're also given this is the diameter, so this side, this arc will equal 180. So 150 here because using subtraction, anybody using what you already have. And this will be 150 minus 30, which is 120 divided by 2, 60. Okay, x. We're given this inscribed angle again, so that's going to be 70. Using this, you get 70 minus 20, 50, 25. Okay, so 18. So we're given this is 90. This is so this whole entire thing is going to be 180. So this is going to be 180, right? And then this side's going to be 180. It's kind of hard to draw that out, but it's going to be 180. Okay, so looking for x here, and that's exactly what we drew here. So this is going to be 180, and that's going to be 40. So know that we got 180 here, we can use the intersecting chord theorem. So 180 plus 40 divided by 2, so that's 220 divided by 2, 110, and you get 110 as the answer. Alrighty, so you got 45 as angle here, 150 and x. How are we gonna do this one? Let's see. I'm just thinking, kind of a little bit. Oh, right. Okay, so I didn't realize that they've given us 45 here. So using the theorem we talked about, which was the secant tangent inscribed angle measurement theorem, we can actually, instead of finding the angle, inscribed angle, you could find the arc just by writing it out a little bit differently. So it's gonna be 45 is equal to half of 150 minus x, and that's gonna be 75 minus x equal to 45, and then 45 minus 75 is, wow, I am just tripping up, bro. My math is just not on point. Negative 30, so 30 is equal to x. Last problem. we're looking for x here. So if we're given that this arc is 130 and this angle is 40, what are we looking here for? We're looking for that angle. So for this final problem, I looked at it a little bit, and the best way to do this is by finding this angle here, and we can do that because we have 130 here, and we're looking for this outer arc, which is simply 360 minus 130. So it's going to be 230. So the arc is 230. Then we can find this angle by doing 230 minus 130, which is 100 divided by half is 50. And we can easily, using the triangle is equal to 180. 40 plus 50 is 90, so this has to be 90 as well. So that's how you solve that problem. If you guys enjoyed the video, be sure to smash that like button if you made it through the whole entire thing. If you guys learned something new today, and I'll see you guys in the next one. See you guys.